So good afternoon, everyone. Thank you for coming. Today we're joined by Dr. Mark Lewis, Director of Defense Research and Engineering for Modernization, and Mr. Mike White, Assistant Director for Hypersonics. Both Dr. Lewis and Mr. White work under the Office of the Undersecretary of Defense for Research and Engineering. Today's briefing is going to be a little different than most of the other press briefings that we hold. And given the considerable interest in the Defense Department's development of hypersonics technology, we will have brief opening statements and then open the floor for your questions, and that's the main reason that we're here. That said, please understand that there are some elements of the program that we're not going to be able to talk about because of the sensitivity of the subject. So we have 30 minutes for discussion. I'll ask that each of you please raise your hand to be recognized and please state your name and your affiliation. So that said, I'll turn things over to Dr. Lewis and Mr. White.
Great. Does this work? Well, first of all, thanks everyone for coming. It's great to see so many familiar faces in the audience. So for those of you who don't know me, and as the Colonel just said, I'm Mark Lewis. I'm the Director of Defense Research and Engineering, overseeing the modernization portfolio for the department. We have 11 modernization technology priorities in that portfolio, including hypersonics. And essentially those priorities come directly out of the priorities that were outlined in the National Defense Strategy from 2018. A little bit of background on myself. So I've come to this position immediately from the Institute for Defense Analyses. Spent most of my career as a faculty member at the University of Maryland and Department of Aerospace Engineering. And spent 4 years in the mid-2000s as the chief scientist of the U.S. Air Force. And I've been in place, I guess, since early November, so I'm no longer the new guy. So with me, and the guy who's going to answer all the hard questions, is my assistant director for hypersonics, Mike White. And Mike has also been in the hypersonics field for can I say decades?
Yeah.
Decades and decades. We both started as child prodigies. And he's overseeing our activities, including the team that is coordinating our hypersonic efforts across the department. I will tell you that fielding hypersonic weapons, although it's one of a number of priorities, it certainly is one of our very top priorities. And in assembling that priority, we look at options across the board. Hypersonics isn't just a single thing. It's a capability that includes land, air, sea options. And our ultimate goal is simply we want to dominate future battlefields. So our job in R&E is really help to foster a unity of effort across the departments, working with the services, working with the agencies. And we have a focus on both offensive and defensive systems. But we're also looking at such issues as the industrial base and industrial base requirements to ultimately produce hypersonic capabilities at scale. I'll tell you, since coming to this position, I don't know of any part of the portfolio, in the modernization portfolio, where I see such close coordination between the services and the agencies. It really is a good news story. Interactions between Air Force, Army, and Navy should make the American taxpayer very proud. So with that, let me turn the floor over to Mr. White.
Thank you, Dr. Lewis. As Mark said, I'm Mike White. I'm the Assistant Director for Hypersonics, so in that role I have the responsibility for integrating and coordinating across the department on all of our hypersonic activities, both our offensive systems and then our defense against adversary hypersonic systems. I came to this job in November, essentially the end of October of 2018, retired from the Applied Physics Laboratory after 37 years there, most recently as the sector head for air and missile defense. Leading a team, very large team of over 1,000 people working air and missile defense for the Navy and Missile Defense Agency primarily. But that was just the last stop in a career that spent several decades working hypersonic systems and then strike systems and then defensive systems. So coming to this role, really it was the opportunity to pull 37 years of experience together to look at the offensive and defensive capabilities necessary to field transformational capabilities associated with hypersonic systems. I say that way very purposefully. We really are talking about transformative capabilities and developing those capabilities by leveraging hypersonic systems. It's not about hypersonics for the sake of hypersonics. Our previous endeavors in hypersonics have been mostly in the research and development and S&T realm, and we've kind of failed in the past to make that transition from S&T and R&D over to application to weapon systems. And that's really what has changed now. We have accelerated our transition of capability based on hypersonic systems, with the most recent budget cycle in FY20 that we're starting right now. And the idea really is, how do we make sure that we're going to deliver to the warfighter in as most expeditiously as possible transformative capabilities that maintain our battlefield dominance in future engagements. So with that, I'll just say that we are happy to be here as a team, helping to lead the integrated activity across the services and OSD to field those capabilities.
So we're the first to Tony.
Tony Capacity with Bloomberg News. Two quick questions. What system will be the first to be test flown this year? And then I had a second question.
We will fly the Navy or the Navy Army derived capability from the Conventional Prompt Strike program. That was the OSD-led effort prior to tomorrow.
Window-wise?
The dates are classified, but it's later this year.
The second question. You have said repeatedly that you want your workforce to not be afraid to fail.
Mm-hmm.
At what point does a failure, though, become a waste of taxpayer dollars? You've mentioned that taxpayer will be happy with the coordination between the services, but what point does it become a billion-dollar fiasco?
So let me take that one. You know, I put failures into two categories. There are noble failures and there are dumb failures. Noble failures. Noble failures are when something didn't work the way you thought it would work, but it wasn't for lack of effort, and in fact, in that process, you learn from that. That's a noble failure. In fact, sometimes the noble failures are the most informative things you can do in a flight test, because you learn from that and you move forward. There are the dumb failures where, fins fall off and squibs don't do what they're supposed to do, and those are the ones that we definitely try to avoid. And that's why I say in flight test, our teams need to be able to fail, but fail for the right reason. So that's not a license to make bad decisions. It's not a license to take unnecessary risk. It means formulate our plans correctly, formulate our plans well, but maintain that experimentalist view in order to learn the most that we can from these activities.
Thanks.
I think that's really an important point. I'll just add to it real quickly in that we are still in the discovery and invention phase and the design phase in all of our systems right now. And so you learn through experimentation. So the upcoming flight test is called Flight Experiment 2. We're still doing flight experiments prior to transitioning to weapon system prototype testing. And so there will be discovery. And like Dr. Lewis said, we don't want that discovery to be associated with, oh, we should have had better systems engineering rigor. We want it to be discovery associated with the hard problem of flying hypersonic systems.
Thanks.
Right.
So let's stay on the front row first, and then we'll go back.
Yes, John Turpak, Air Force Magazine. Dr. Roper spoke to us on Friday in Orlando about Hacksaw and Arrow and why the Air Force went with Arrow. And he was talking about that gives the Air Force an opportunity to start developing the industrial base and choose suppliers and whatnot. I'm wondering, isn't that a little premature, number one? And number two, if Arrow is supposed to be based on the TBG and they're operating in parallel, how does Arrow learn from TBG if it's actually a little ahead?
Do you want to take the...
Sure. So Dr. Roper's comments on Friday really described this difficult decision that the Air Force had to make in stopping Hacksaw at the CDR, which is later this month. And that decision really was budget-driven. Ideally, the Air Force made a very aggressive, lean-forward decision a couple years ago to not only put one hypersonic program in place, transitioning from the S&T world to a weapon prototype world, but to realize that involved risks and to put a second one in place in case those risks were realized. Both systems have been matured, and we're in the process of taking those systems up to CDR level of development, and the Air Force made a difficult budget decision in 21 that basically said, hey, the envisioned desired system is associated with TBG and Arrow. We need to place our bet now, and then we'll wrap Hacksaw off, put it on a shelf, and be able to pull it off if we need it, but we want to focus our energies on Aero to make sure that that's successful.
I should point out it was a decision that we in R&E fully supported. We think the Air Force made the right technical decision as well. I mean, given the constraints that they had picking between their systems, they made the right technical decision. Now, having said that, you raise a great question, which is that Aero is leveraging efforts under the DARPA TBG program. And we've got really good connectivity now between DARPA and the Air Force to make sure that they're working hand in glove. That DARPA understands the importance of what they're doing and how it factors into the Air Force activities. And that's something that we in R&E are really quite focused on.
So if I could quickly follow up, then. He also mentioned the idea of having dual producers and competitive procurement later on.
Yeah.
Are you talking about taking one design and giving it to two companies to produce, or are you thinking about a slightly different variation of the idea?
So we're not really talking about one design and multiple producers yet. We're talking about variations on the idea. In part, I'll come back to, we're doing flight experiments, and we want to have a range of options available for the various systems we might pursue.
We're putting together an acquisition strategy. So we've transitioned from R&D to weapon prototype. The next transition is from weapon prototype to acquisition of actual weapons, and that's where the acquisition strategy will come into play, that whether we have competitors and the like.
So let's go here, then we'll go with Patrick, and then Teresa, and then...
Hi, Steve Trimble with Aviation Week. So on the air breathing side,
Right.
Can you lay out when you think there could be an air breathing version of what we're doing with Aero and CPS and LRHW, and what would that look like? Is it strictly air launched? I mean, you could take that and make it ship launched or surface launched. Is there any interest in doing that, or would it be completely different programs?
Yeah, so we're looking at a broad set of air-breathing options. I really wouldn't characterize it as an extension of TBG or Aero. Those are boost glide systems. It's a completely different configuration. But we are looking at air-breathing hypersonic cruise missile configurations, initially primarily focused on the DARPA Hawk program and the transition of that to an air-launched cruise missile configuration with the Air Force. But we're also looking at some other configurations that have a broader range of capabilities. One of the side benefits of the Air Force stepping away from Hacksaw and putting a bow on it at CDR is they can now focus on the air-breathing transition as a second potential hypersonic transition opportunity.
Can you define what would be the mission for the cruise missile versus the boost glide system?
The mission for the cruise missile has to do with, or the value proposition, let me put it in that term. The fact that the cruise missile is smaller, so it's more affordable, and it fits on a wider range of platforms. So that one of the big values it brings to the table is loadout and the ability to deliver weapons to the theater. So instead of having a small number of weapons on the bomber platforms, we can put weapons, large numbers on the bombers, as well as the 4th and 5th gen fighters, and so we can bring a lot more to the table as far as platform compatibility and flexibility.
Yeah.
The other thing is that it's easier to integrate a seeker on a cruise missile, and so the ability to use a cruise missile for attack of targets that require seekers is a value.
But the boost gliders, in many cases, have some range advantages and some other trajectory advantages. So that's why we at this point we really don't want to see an either/or. We actually want to see both technologies pursued because they both play well.
It's definitely a weapon mix, and they complement.
Right. I've referred to it as kind of a high-low mix, if you will, kind of the hypersonic analogy to the F-16, F-15.
Just go to Patrick.
Thanks. The test that's happening later this week, or excuse me, this year, could you go into any more detail about what exactly you're testing? Are you testing the ability of the system to hit a precise point on a target grid? Or are you testing flight and operation in the air? Or what exactly will you walk away from that test having learned?
So the test objectives for the upcoming tests that you're referring to, FE2, have to do with the hypersonic glide body, the common hypersonic glide body, and the ability of that glide body to execute a mission consistent with the future weapon application.
Does that mean hitting a specific?
I'll just kind of leave it at that. I mean, all the things from beginning to end that you think you might want to do with a weapon configuration, we will demonstrate in that test.
Yeah.
All right.
So I think we're at Teresa now.
Yeah. Teresa Hitchens, Breaking Defense. I'm a little bit confused about exactly what the TBG program is doing. As Dr. Roper said, it was kind of the precursor for the Aero program, but it's a DARPA program. Is the Air Force the only customer that you're seeing now? Has this like narrowed down to this is dedicated to an Air Force program taking over?
The primary program that is the weapon prototype transition for TBG is the Air Force Aero program. But there is DARPA work going on to look at using alternative launch platforms and alternative basing means for the TBG glide body. Those systems are not funded to do weapon prototype transition as of yet.
Right, but don't be surprised if you see eventually evolution of the TBG program into other systems.
Into other services.
Yeah. Yeah.
Thanks. Aaron Mata with Defense News. Thanks for doing this. Mark, you mentioned at the top the industrial base and that being an aspect that you're looking at as well. Can you speak to your view of the industrial base as is now and whether it kind of has the capability to develop and eventually produce the type of hypersonic weapons and the quantities that you're looking for? And if it's not at that point now, where you think that needs to grow?
So we're actually doing that study right now. So Undersecretary Lord set up a hypersonic war room that I'm right now co-chairing with Assistant Secretary of Defense Kevin Feige. And we are probing those exact questions. Right? What is the state of our base? Is it positioned to produce at the scales that we're anticipating? And there are a lot of moving parts to that. We're obviously in a position now to develop the concepts. We develop the prototypes, but producing at scale, as you know, is a different proposition. I'll give you just one example. As we pursue air-breathing systems, we're looking at what are the technologies associated with producing a supersonic combustion ramjet engine. And it's not just materials; it's production capability, it's manufacturing capability. High temperature material is obviously another one that we're really interested in. What are our capabilities now, and again moving into larger and moving in the sorts of numbers that we're ultimately envisioning. If I could also say, another important piece of this is workforce. And to that end, we've got a really strong focus on the universities. So Mike's team is putting together a university consortium that is hoping to leverage the best and the brightest in the university community. And hypersonic funding at the university level has tended to be somewhat periodic. It suffered periodic cycles. There's this 15-year periodicity when we drop a lot of money in the universities and then our programs go away and we stop doing it. We're looking to get out of that cycle. We're especially interested in leveraging parts of the university community that are, if you will, the non-traditional players, the folks who haven't done the basic high-speed fluid mechanics, maybe that can bring other capabilities to bear, guidance, navigation, control, material development, systems engineering, and we think it's important not only for developing the concepts, but obviously to make the workforce available in industry as well as in our government laboratories.
Can you tell us when you think that study might be done? And just gut level, I know it's something you're working on, but do you feel comfortable?
So we're in a pretty short time fuse with that. So we're looking next couple of months to have that industrial base war room kind of start delivering its initial reports. We just started on the endeavor, as I mentioned. I suspect it will also be it will be an ongoing activity. We need to continue engagement with our industrial partners. We're looking for, honestly, we're looking for, critical nodes in the supply chain, right? We want to make sure that we're not just at the tier 1 suppliers, but we're looking, what other suppliers are necessary to provide at scale.
And we're also looking to make critical investments in advanced techniques and capabilities that get affordability into the equation right from the start.
Right. Exactly.
Well, let's go over here.
Hi, Abraham Asher, the Washington Examiner. Thank you for doing this, and please forgive me for not knowing the subject so well. But how is it that Russia already has this capability, and where are we in our development compared to where they're at now?
Yeah, I think that's a great question, and it's one we get a lot, really, and it really has to do with one of the comments I made earlier, in that in past decades we've been world leaders in hypersonic technology, but we have consistently made the decision to not transition that to weapon applications and build weapon systems out of the hypersonic technologies that we were working on in the laboratory. The Russians and the Chinese, quite frankly, have both done that, and they've done that quite a number of years ago. And so it's that transition to application that that got their efforts jump-started, and that's what we're accelerating now.
Right. So the Russians have been working in the hypersonics field for quite some time. I mean, they started around the same time that we did, and they built on that. And you know, we see them essentially building on the Cold War Soviet Union legacy. China's a somewhat different story. So China's come to it a little bit late in the game, but they've made some huge investments. And I also like to say we did their homework for them. Right? Hypersonics is a field that was basically invented in this country. We did the basic research, we developed the concepts, we did the fundamental experiments, starting in the late 1940s. And you know, we've published extensively, and they've read our papers. So we made it relatively easy for people to pick up the ball from us.
Quick follow-up to that.
Yeah.
Why now? If we've allowed them adversaries to advance their capabilities, why are we right now deciding, and as opposed to having decided to ramp this up before to weapons capabilities?
Ooh.
I think there are a couple answers to that. You know, one has to do with making sure that we do not allow to stand an asymmetry in capability between us and our potential adversaries. And so what they're doing to accelerate towards weapon transition and fielding, for that matter, we can't allow that asymmetry to stand. But I think more importantly, the world has become a place where our great power competitors have watched us over the last several decades, and they see the systems that we've developed and matured to establish our domain dominance in space, on land, at sea, and in the air. And they have systematically developed counters to that sometimes people call A2AD, anti-access area denial, where they have systems that try to deny our domain dominance in all of those areas. And it really is those threats and those targets are what are driving our investment in hypersonic strike capabilities in particular. So it's really driven by the buildup of our great power competitors and their attempts to challenge our domain dominance.
I'd also give credit, you know, we have documents like the National Defense Strategy that kind of lays out a focus on peer competitors. Frankly, I think we also have leadership in this building that understands the threat and has stepped up to the plate, if you will, and is addressing it now.
Let's go over here for a new question.
I know none of these efforts are supposed to have nuclear warheads, but is that something that the DOD is studying and looking into as a possibility for?
Our entire hypersonic portfolio is based on delivering conventional warheads.
Right, strictly conventional.
Russia and China are looking into that. Is there a reason why you guys are not right now?
We do not feel like there's a need to do it. Our strategic and our nuclear forces, while undergoing modernization at this time, that's a separate activity from our hypersonic activity.
Yeah, honestly, it's not the value that we see. We don't see value.
Hi. So follow on to that, the strategic implications. We've talked to people who say that this is potentially destabilizing, and that through the reaction time and the ability to evade defenses, that it incentivizes the first strike option. I know that's not quite in your lane, but I'm sure you have thoughts about it. And how does this affect that balance?
Well, I certainly think that it's more destabilizing if they have them and we don't. And so, in order for us to be able to remove that asymmetry I described to you earlier, and we have to be able to counter with similar capabilities when the time comes. And then there are a set of targets and missions that you really need these systems to be able to accomplish. And if you can't accomplish those missions, then you lose the deterrence of our broader forces. And without that deterrence, I believe that's more destabilizing than if you have a deterrence. So, the first real objective is to make sure that we are holding adversary capabilities at risk and we maintain our military deterrence and our strategic deterrence with our warfighting capability.
So let's go to Patrick and then to John and then someone who maybe hasn't asked a question after that.
Thanks. Quick question on the Defense Regional Glide Phase Weapon Systems Interceptor. So the request for RFP is out. Assuming that you get in the papers that you like, what are the milestones that you're looking for that in the years ahead? And are there any lessons to be learned from previous interceptor programs like RKV that you can apply to this, do you think?
Yeah, I think there's a lot to be learned, but I will just offer that it's a very different problem than exo-atmospheric intercept. Intercepting hypersonic systems within the atmosphere presents significantly more challenge than intercepting ballistic missiles out in space. So there's considerable technology maturity that's necessary. So the Regional Glide Face Intercept program is really focusing on identifying and maturing the technologies associated with the interceptor necessary to intercept hypersonic systems with their high speed and maneuverability within the atmosphere. So there are a series of milestones in place to look at that technical maturity and then to demonstrate that technical maturity through a series of flight test demonstrations moving towards identifying a preferred concept for ultimate weapon interceptor development.
What's the flight test demonstration schedule, do you imagine?
Mid-20s is what we're shooting for.
Yes. Can you talk about investments that are being made in wind tunnels? And you're going very fast.
Yeah.
Are you at risk of outrunning the capability of the infrastructure to test what you develop?
Yeah, that's a great question.
Yeah, we love that question.
So our national T&E, test and evaluation infrastructure, is managed through the Test Resources Management Center. They have responsibility for significant investments we're making in a test and evaluation for both ground test and flight test. So as you might imagine, with the number of programs and the pace of testing necessary to mature those programs on the ground, we need additional wind tunnel capabilities, and we're making some investments in that direction, primarily at the Arnold Engineering and Development Center in Tullahoma, Tennessee, the Air Force facility that houses many of our hypersonic wind tunnels, including some of our hypersonic facilities that allow us to do arc jet testing or very high temperature testing of materials. So some investments are going in there. And then we're also making significant investments to open up the aperture relative to what we can do for flight testing, where we do that flight testing, and the techniques that we use to gather data and do telemetry and all the things necessary to handle the high pace of testing coming forward.
Yeah, so we've had some good news stories. The U.S. Air Force has recently upgraded its hypervelocity tunnel number 9 up in White Oak, Maryland. They've taken it from a Mach 14 facility to a Mach 18 facility. Our friends at NASA, down at NASA Langley, have been working on upgrading their nozzle for their 8-foot tunnel, which is one of our prime high-speed engine testing facilities. We've got other facilities going in around the country, including some very respectable facilities going in universities. University of Notre Dame, for example, is building a quiet supersonic tunnel, which is essential for understanding how the flow right near the surface of a vehicle behaves. But as Mike said, we've got a very aggressive schedule. We are pushing the limits of our test capabilities, especially if we're flying at the rate that we hope to be flying, and we're cognizant of the problem and addressing it.
And test ranges, where will the initial ones be, do you think? Is it over the CONUS or out in the ocean?
We're flying mainly in the Pacific, so out of PMRF for the longer range flights, and then off the coast of the West Coast for the shorter range flights.
Right.
So we've got a couple of minutes left. Anyone else who hasn't maybe had an opportunity to ask a question? Quiet group. All right.
Great. So, fundamentally, where we are today, I mean, we're a couple of years from fielding LRHW, Aero, then after that CPSIR. But, I mean, I've talked to physicists, and you know them, and I've talked to you. Being able to predict the transition to turbulent flow, the materials that are required in the development of being able to mass produce them, inlets for air crews, these all seem like still open questions in the research community. How close are we really to solving those things, or getting to what would normally be considered like a mature capability like JASM or, these things that we know and they aren't science?
So I would say the technology is frankly quite mature. So you talk about inlets, for example. So we flew a scramjet-powered system for long duration starting in 2010. That was the X-51 configuration. And the key technologies are not only the inlet and the integration, but also the engine operation, building an engine that was actively cooled by its own fuel. We showed we knew how to do that a decade ago, and we've had a decade's experience of investments to take that forward. materials are always a challenge, but our knowledge of boundary layer flows, for example, when a flow is going to go from laminar to turbulent, is far, far more sophisticated than it was even just a few years ago. And in part, that's been informed by some of the past programs that we've done. I'll highlight the work that we've had done at Air Force's Tunnel Number 9, the hypervelocity tunnel that I just mentioned. They've done an exquisite series of tests helping us understand the behavior of flow on the surface of a vehicle, heating effects on the surface of a vehicle. We've also improved our diagnostic techniques. So if you look at the diagnostic tools that we have available today in our wind tunnels, even flight test, we've come a tremendous distance from where we were 10 years ago. So we're really very confident. We think it's I don't want to misrepresent the fact there's still development underway, but we have tremendous confidence in the ability of this technology to perform as expected.
Aaron?
So this is kind of a rejection question, which I know you guys love, but so we have all these different programs going on. We know that there's been a lot of talk about making sure the services are talking to the agencies and everyone's working together, et cetera, et cetera. Yeah. We saw the Air Force cut one for budgetary reasons. I'm wondering, going forward, are you guys expecting to have a number of hypersonic programs to perhaps continue to grow as certain areas need to be developed? Or are you envisioning that mid-2020s, towards the end of the decade, we get down to maybe 1 or 2 hypersonic weapons, which is shared by everyone?
So I would say no, it's not going to be 1 or 2 hypersonic weapons. And coming back to hypersonics isn't a single thing. It's a range of capabilities, right? It's intermediate range, it's long range, it's things coming off of ships, it's things coming off of trucks, it's things coming off of wings of airplanes and out of bomb bays. It's a full range of capabilities. So no, I don't expect us to zero in on just 1 or 2 things and stop there. I expect the development efforts to continue. At the same time, we have a very strong focus on delivering real capabilities, getting these things out of the laboratory, getting these things out of prototypes, and getting these into the hands of the warfighter. And that's our primary focus now. So.
Yeah, I would agree 100% with what Mark just said. And I'd urge you to think about warfighting capability versus hypersonics as a thing, as Dr. Lewis just said. And if we project the adversary capability that I described to you earlier to challenge our dominance in the warfighting domains, that's not going to get easier, it's going to get harder. And I think there will be more and more drive for advanced weapon capabilities that you can field with these hypersonic systems. And I see it being more of a proliferated capability than just a niche kind of thing.
So we're right at the end of our time. Sylvia, you just came in. Did you nod to me like you wanted to ask a question?
Oh, I would like to ask a question. Thank you. Actually, you say that they would challenge your dominance, the U.S. dominance. But there are some experts who say that it's not really true that the hypersonics are not impossible to detect and impossible to stop, and that actually you could keep the dominance without all these expensive products.
So you can detect hypersonics, but it's very difficult. The nature of these systems, the way they fly, the way they operate, their trajectories, it makes it very, very challenging. It also, even if you can detect them, it's very difficult to respond because you don't have a lot of response time, right? In military terms, we like to talk about the OODA loop: observe, orient, decide, and act. Getting inside an opponent's OODA loop, getting inside their decision processes, makes it difficult for an opponent to respond. Well, these things capture that because they're moving. The time scales are so small. Having said that, we certainly have an emphasis on the defensive side. We are looking at ways of doing the detection. Our Space Development Agency, for example, is very much focused on technologies that would help us detect these systems. Similarly, once you've detected them, stopping them. Yes, we think there are ways to stop them. We have defensive systems, but they're not going to be 100% effective. More importantly, I'd say that hypersonics is something that we'd want to pursue even if adversaries were not, or potential adversaries were not. It's a military capability. I put it in the category very much as when we developed stealth capabilities, stealth technology. With stealth, our systems were invisible to radar. With hypersonics, our systems are perhaps visible, but they're harder to stop. And that's the advantage that they bring to the battlefield.
So, ladies and gentlemen, we're out of time. We ran a little over because we were a little late starting. If you've got any questions that you did not get to ask, please send them to me, and we'll try to get the responses back to you as quickly as we can. So, thank you very much for joining us.
Thank you.
No, thank you. Thanks all.